Hi, everyone. This is the end of lesson 2, so we didn't quite finish this off the other day. But just to remind you, we were going through the beginning of combinations, and we talked about what combinations are. They're really just permutations, but when the order doesn't matter for specific situations. So we looked at some examples. The classic one is when you have groups of things, like in example 2 here, 3 people on a student council would be a group. If that group doesn't have specific positions, then the order doesn't really matter. And so we can consider it a combination. And from that, we came up with this little formula where we actually add this extra r factorial in, where we divide by the number of items chosen. Because the order of those items, because there isn't anywhere to put them, it's just one big group, the order doesn't matter. So there were several ways to express this, and that's illustrated there. We went through this example, and then you tried some of those questions for homework. So let's look at some application stuff in here, and we're actually going to take today's lesson and lesson 3 that goes through some of the more complicated stuff. So the key in these questions is to recognize, the most important part is that if it's a permutation or a combination, and you're almost always at this point going to be focusing on combinations, because that's really this unit. But we'll talk about it as we go through. So let's say we have this situation where it says Pete runs a landscaping business. He has 12 kinds of rose bushes, 16 kinds of shrubs, 11 kinds of evergreen trees, and 18 kinds of lilies. How many ways can Pete fill an order if a customer wants the following? So the first one is he wants 4 roses, 3 shrubs, 2 evergreens, and 6 lilies. In these cases, if you have an order or you're buying something, it doesn't matter if you buy something first or last or anywhere in between. The order doesn't matter. You're still getting the same product. It's kind of like the sum of money when we talked about that last class. So these ones, because it's an order, it's implied that the order doesn't matter. So we're just filling some customer's order where the order of everything doesn't really matter. And so we have to consider how many different ways can we get each of these items. So if I have 12 overall rose bushes and I want to select 4, you have a situation like this. You have 12, choose 4 of them. And that gives me the number of ways that I could choose any of those 4. The next one would be, you've got 3 shrubs, so this is 6 out of 16. So we have 16, choose 3. Because it's filling an order where it's one single order, this can happen at the same time, and so it's a different arrangement, so I multiply. We'll look at the next example where you don't multiply and the difference between the two situations. And I keep going like this. So the next one was 2 evergreens out of, I guess there's 11. So we've got 11, C2, and then times the next one, you want 6, and there were 18. So I have 18, C6. So just to illustrate, these are my roses. This was the shrubs. This is the evergreen. And then the last one was the lilies. So you could write this out like in a very similar way. Sometimes you'll see it written like this. It means the exact same thing. 12, choose 4, times 16, choose 3. And so a lot of people probably prefer this second method because it's just less writing. And it represents the same thing. So you would punch all this in to your calculator using the combination button and then multiply those values together. So if I do that, I end up with a big number, of course, and 2.83 times 10 to the exponent of 11. Oops. So if we compare that to the second question here, it says they want to fill an order that has either roses or lilies. And again, we've talked about this language, but if it's or, meaning not at the same time, so it's either you're going to have these things or you're going to have these other things, not both together, we know that this means that we have to add. So we can just take our numbers. So 4 roses, so that's this 12, choose 4, because there were 12 to choose from. And then I add the next one, which is lilies, so I have 18, choose 6. And again, you could write it either way you want. So I punch that in. And I get my answer. Okay, let's try a couple other ones. Again, it take a little practice to get used to. So the next one says, how many ways can 6 people be selected from a group that consists of 4 adults and 8 children if the group must contain exactly 2 adults? So how many ways can 6 people be selected from a group that consists of 4 adults and 8 children? So we want to make a group of 6. If they say it has to have exactly 2 adults, what does that imply about the number of kids? So this would tell me that I've got 4 children. And I know that because I've got to need a group of 6. So that's the first thing. This implies the order doesn't matter. There are not positions for these people, so it's just a group. Anytime it's just a group, it doesn't matter if you're selected first or last or anywhere in between. So order doesn't matter. So we know we're in combination situation. So within this group, it is just one group. If I have 2 adults and 4 children, I can choose my adults, let's just deal with them first, from a total of 4. So I've got 4 adults to choose from, and I want to take 2 of them. So I'll use this notation, 4C2. So these represent my adults total. And that number will always be bigger than the R number, the number you choose. And within the same group, because it's in the same group, I'm mixing them. And so you're going to multiply between. I have then 4 children. So I know I want to choose 4. And how many were there to choose from? And that's this 8 children, like that. So I've got this number for my adults and this number for my children, and that's the total number of children. And so again, you can just punch this in, and if you want to, you can just jump right to the final answer, which becomes 420. So the number of different ways I can have that group. So the next one, slightly more challenging. It says, how many ways can 6 people be selected from a group that consists of 4 adults and 8 children if the group must contain at least 2 adults? So at least, and again, the language is really important. If it's at least 2, and we have a maximum group of 6, but we are limited in this case because there are 4 adults to take. And so I can only go, if it's at least 2 adults, I can go 2, 3, or 4 adults. So I max out because there's only 4 to choose from. So in this situation, notice I wrote or. So 2 or 3 or 4 adults, because I can't have 2 at the same time as I can have 3. So I know that I'm going to have to add things together. So separate situations. So we already figured out when there were 2 adults above. So that's this thing. So 4C2, which implies to fill that group of 6, I still have 4 children to take with them. So this is my 2 adults, 4 kids. Separately, I can have a situation where this changes. And so take a moment, try not to just jump to this answer, but take a moment, see how that would change if it was 3 adults. So what numbers change in this little formula? And then separately, I'm going to have also 4 adults. And it's really good practice because this is kind of a skill that is really used a lot within these combination questions, where you just really are changing a couple numbers. So if I wanted 3 adults, and again, try this on your own, so pause the video, see if you can come up with these. So I got 4C, this is going to be my 3 adults. How does that affect the number of children? Again, remember, it's only going to be a maximum of 6 people. So I've got 3 adults. That implies that I also will have 3 kids. So I have 3 adults, 3 kids. And then the last one, we're going to have 4C4. So I'm taking all of them. And just so you know, that number 4C4 just becomes 1. There's only one way to choose a group of 4 people from a group of 4 people. You have to take them all. The order doesn't matter, so it's really just 1. So it saves you a bit of work if you don't want to punch that into your calculator. And that implies that I would have 2 children to complement that group of 6. So I have 4 and 2. Notice, I'm going to highlight all these choosing things. 2 and 4 gives me the group of 6. 3 and 3 gives me a group of 6. And then 4 and 2. All of those numbers will add up to the total number, I highlighted in blue above there, the total number of the group size. So they'll always work out that way. So we take all of those, we punch them in, and you can give that a try. And it is good practice to be able to do that, and you punch them all in, you get these numbers, and total gives me 672. So that does it. So this is kind of the beginning of combination questions. There will be some more challenging ones in the textbook, but you've got today's class to work on these. Again, help each other out, and I will have the solutions in OneNote for all of those questions so you can check it out. Okay, take care. And also, I'm assuming you've finished these. If you were away at the last class, make sure you've got all of that done. Okay, bye-bye.